I'm going to be taking up question 1 on page 11 of the Dynamics Workbook, and it's going to be found in topic 3. So I'm not going to read out the question, but essentially what it tells us is the mass of the boat, and it's about one tugboat being pulled by 2 tugboats as shown here, and that tells us the force that tugboat 1 is pulling on the main center boat, and it tells us the angle by which it's being pulled at, and then the same thing for the force that tugboat 2 is applying on the main tugboat, and then what angle that's being pulled by. And then it also tells us that the boat is being pulled at by a constant velocity, and the unknown of this question is the resistive force. So what we're trying to find is what is the resistive force acting on the boat. So like any other question similar to this one, we want to start by establishing a reference frame. So I want to make north be positive, south be negative, I want to make east be positive, and I want to make west be negative. So once we've done our reference frame, the next thing you want to do is make a free body diagram. I'm going to start by drawing our F resistance force, and this is our known, what we're trying to find. And I'm also going to add in what the question calls tugboat 1. I'm going to call that F1, and it tells us that F1 is 5,500 newtons, and it also tells us that F1 is being pulled at by an angle of 35 degrees south of east. And then it also tells us F2, which has a value of 4,907.8 newtons, and the question tells us that it's being pulled at an angle of 40.0 degrees south of east. And what we also want to do for a free body diagram is divide this into x and y components. So here would be F1x, then our F2x, then here we would have our F1y, and here we would have our F2y. And I find it helpful if you color code it, so I'm going to make F1x and F2x pink, and then I'll make F1y and F2y blue. So that's all we need to do with our free body diagram. And then another thing we can write from the question is the mass of the tugboat. Even though we don't end up actually using this value, it's important to write down your givens anyway in a question. And the last thing I want to note from the givens is that it's being pulled at a constant velocity. And this can tell us a lot of things. It can tell us that the acceleration is 0 meters per second squared, but more importantly for this question, it tells us that the F net on the system is 0 newtons. And that also means that the F net in the x direction is 0 newtons, and it tells us that the F net in the y direction is 0 newtons. So this is going to be very important later on in the question. So now we're done with our givens, and essentially what we need to do to solve the problem now is figure out the total applied force in the x direction going east. And then since we know that the F net is 0, that the F resistive force is going to be equal but opposite to the F applied, the total applied force going east. So we could start solving this by using the spreadsheet strategy, which would look like this. So we can start by finding F1x, which is going to be the magnitude of F1 times cos of angle, and we know that we're using cos because of SOHCAHTOA. If you see here, adjacent over hypotenuse, and we're trying to find this, the adjacent side. So we know to use cos, and then we just have to sub in our values here. So 5,500 newtons times cos of 35 degrees because it's F1. And I've already calculated all the values for this question, but the answer you should get is 4,505.3362 newtons. And that is your value for F1x. Now for F2x, you want to do the magnitude of F2 times cos of angle, cos of theta, and you know that because of SOHCAHTOA. So now you just sub in your values again, times cos of 40.0 degrees, and the answer you should get is 3,759.5929 newtons. There's probably going to be more decimal places after that, but 4 is enough for this question. And there is your answer for F2x. And I'm also going to color code these. Since both of these are X, they're both pink, and that matches with our diagram. Now, to find the F1y, it's going to be the magnitude of F1 times sine of theta. So now that changed because of SOHCAHTOA. And then we just sub in our values like before. And sine of 35 degrees. And the answer you should get is 3,154.6704 newtons. Then we can use that and we can solve our F2y. And for F2y, it's going to be the F2, the magnitude of F2 times sine of theta. Except for this formula, there's one little difference. If we go back to our diagram, we know that F1y is going to be positive because it's going north, and according to our reference frame, north is positive, but the F2y is going south. So because of our reference frame, we need to acknowledge that this value is actually going to be negative because it's going down. The reason why both F1x and F2x were positive was because they're both going eastwards, and that also makes sense based on our reference frame. So for this one, it's just the same, except we add the little negative in front here, and then we just sub in our values like we have for these other ones. Sine. And the answer you should get for this question is negative 3,154.6730 newtons. So that is all of our x and y components for the question, for the angled forces. And now what we can do is find out our F applied y and F applied x. So the F applied in the y direction is going to be F1y plus F2y. So we just sub in our values that we've already solved for up here. Plus a negative value, so we have to include that as well because they're both going in opposite directions. And the answer you should get is negative 0.0026 newtons. And because you can clearly tell how close to zero this is, it's reasonable to assume that it's just 0 newtons. And this makes sense based on what we're told in the beginning of the question. Because it's being pulled at a constant velocity, F net is 0, F net x is 0, F net y is 0. So it also makes sense that we got this as our formula because it agrees with what the question told us. So now that we've established that the applied force in the y direction is 0, we don't need to worry about it now. And now we need to find the applied force in the x direction. So the total applied force in the x direction is going to be F1x plus F2x. And we'll just sub in our values that we've already solved for up here. And you're going to get and both of these values are positive because they're both going east. And the answer you should get is approximately 8, 2, 6, 4, 9. So that is our total applied force in the x direction. So now what we need to do to finally solve what we're really looking for, the resistive force, we know that these two forces cancel out, and essentially now that we've found the total applied force going east, and we know that F net is 0, we can use those two known values to solve for the resistance value. And we know that the resistive force would really just be equal but opposite to the applied force. And we can also show that using a formula. So it would be F net x, because all the values in the y direction are just 0 now. We don't really need to consider that. The F net x is equal to the F applied x, so this value here, plus the F resistance force. And now if we sub in our values, the F net x is 0 newtons. The F applied x value that we solved for previously is 8,264.9291 newtons, plus F resistance. And now when you just rearrange the variables, you move this force to the left side and it's going to be turned into a negative value. So that means the F resistance force is just negative 8264.9291 newtons. It's equal but opposite to this value, and the reason we know this is because of the constant velocity, which means that F net is 0. So we're not done yet because now we need to consider significant figures. So if you go back to the question, you'll see that the lowest number of significant figures is 2. So that means we can say that it's approximately 8,300 newtons, negative 8,300 newtons. And if we convert that into a direction, we can go back to the reference frame up here, and we see that a negative value in the x direction is west. So we know that it's going to be in the west direction. And that here is your final answer. And if you look in the answers in the workbook, it's the exact same. So now to end the question, end with therefore statement, and you can say that therefore the resistive force to the motion is 8,300 newtons west. You also want to make sure that in your therefore statements you're including your values with their directions, not positive or negative. So that is the answer for this question. And essentially what we did, we started by doing our givens. We found out the x and y components. We found out what the applied force in the x and y direction was. Then, knowing the applied force in the x direction and that F net x was 0, we used that to determine the F resistance force right here. And that's how you solve this question.